sine 2x is equal to 1 over 8. Now guys, you might see the 2x and think, oh, double angle, right? But let's quickly think, if I wanted to change the sine 2x using the double angle identity, what would that be? Don't write this down. 2 sine x cos x, hey? Is that making it easier for me to solve this equation? Do I want a sine and a cos? No. So guys, you even got questions like this last year before we even did double angle identities, right? Remember, in a trig equation, you want trig ratio, angle equal to a number, right? I have that in this case. All right, so that is what we're looking for. Once we have this, we can go straight into calculating our reference angle. So I'm going to make a note, guys, because it's a very common mistake. I think once you learn some new identities, you almost always want to apply it, right? As soon as you see sine 2x, you want to apply it. That's not really the case when we're doing equations. Okay, because if we change it to 2 sine x cos x, it's going to actually give us an equation that we can't solve easily. Okay, so don't use the double angle identity. We use the double angle identity when we're proving identities, right? When we have a left-hand side, right-hand side situation, and we want to cancel things out or get more terms or whatever. Okay, here we want to keep it as simple as possible. So sine 2x is actually what we want. Guys, is this a positive or negative value? Positive, right? So we're going to look for the quadrants where sine is positive. What's that? Which quadrants are those? 1 and 2. So I'm going to have a quadrant 1 solution and a quadrant 2 solution. All right, guys, for the reference angle, shift sign of this number, hey, of 1 over 8. Shift sign 1 over 8 equals, and you should be getting a very small number now, 7,18 degrees. All right, now next step is quadrant 1, quadrant 2. Okay, so quadrant 1, what is the angle that I had now? 2x. So that is now what I need to put in my general solution. In the previous one, it was just x. So now we're going to say 2x is equal to, what do I do in the first quadrant? It's just the reference angle, right? So I'm just going to have 7,18 plus still 360n because we're working with sine again, and the period of sine is 360. Now, guys, I've already written n element of z in the first question, so I don't have to write it again. Okay. If you're worried that if you're not sure, should I write it, should I not? Rather just write it. Okay, if you can't remember whether you have to or not. Now, how am I going to get x on its own? What must I do with this 2? Divide by 2. So just on the calculator, you're going to say 7,18, just the answer from the previous calculation, divided by 2, and you will get 3,59 degrees plus the 360. You must also divide by 2, hey? 180 n. Okay, so guys, in quadrant 1, we always use the reference angle, because the reference angle is always an acute angle, an angle between 0 and 90, and that is what we have in quadrant 1. Okay, quadrant 2. Again, our angle, which is 2x. What do I do in the second quadrant? 180 minus the reference angle, which is 7,18. Again, you must write plus 360n, please, guys. 172,82 degrees plus 360n. And now to get x on its own, I still have to divide by 2. So divided by 2, that will give me 86,41 degrees plus 180 degrees times n. Again, I'm just going to highlight all the 360 ends and then the 180 ends as well. You have to write those every single time. And also, let's just quickly make a note here. If we are working in quadrant 2, we have to do 180 minus the reference angle.